and it is all about the authorization part. Authentication we have covered in the chapter number 3, like how you can configure identity provider. Okay, we have created the users. In this chapter we are going to assign permissions to those users. Okay, now all the permissions in the Kubernetes or OpenShift are controlled by RBAC. RBAC full form is role based access control. Okay, now generally what happens over here, there are three type of objects in RBAC. One is a rule. Okay, rule is actually defined or for allowed actions for objects or group of objects. Like, I hope you have used AWS, guys. In AWS, what we have? We have a IAM user, and what we have roles. In the roles, what we do? We attach policies. What policies we attach? Like EC2 full access. This is a policy. Okay. Now, if this is a policy, this policy is a part of a role, and if we are attaching that particular role to IAM user, then that user can do anything with that particular policy. Means EC2 full access means that user can create EC2 instances, can delete in EC2 instances. We have one more role over there, one more policy, administrative access. Okay, if we are attaching this policy to any user as a role, then the person can do anything with your AWS account. Okay, so this is the concept of role. So the role is having now a role and a binding. Whenever we attach the role to any user, that is called a binding. Okay, now there are generally two type of roles. One is cluster role and another one is project level roles. Project level roles are applied to only projects. Cluster level roles are attached to cluster. Now let me give you the example. The example for the cluster role is cluster admin. Now this is a role. If this role is attached to any user, then that user can do anything with the cluster as he have admin privileges, okay, on the cluster. Number 2, cluster
In
hyphen
chapter 3
status.
chapter 3 exercise, we are adding this cluster admin role in to the user, right? That
Yes,
particular
yes,
admin.
yes. If this role is
Okay.
attached to any user, then that user can see the cluster, but he cannot delete nodes, etc. Okay. Now, project roles are there, like admin. If this role is attached to a user for a project, then that user can do anything in that project. He can create resources, delete resources, change the policies, okay, etc. Number 2, which is edit. The person can do anything within a project, but he cannot manage project roles, okay, or policies. Means he cannot give permission to someone else. Number 3, view. The person can view all the resources inside a project. Okay. And like this, so these are the 3 project roles. These are the cluster role. In the OpenShift, you have many type of roles and many type of project roles. Now, if you want to attach a cluster role, then you run command ocadm policy. If you want to attach project role, then you run command oc policy. That is the difference. Okay. After that, you can use -help to see how the command works. Clear? Now. And one more thing, whenever you attach any cluster role to a user, it is called cluster role binding. Whenever you attach any project role to a user, it is called role binding. Okay. So you will always run the command oc get cluster role binding to get all the cluster role bindings. Oc get role binding to get the role bindings. Now, so cluster role is there, local means project role is there. Okay. How you can attach it? OC, ADM policy, add cluster role to user. What is the role name and what is the username? Same add cluster role to user, cluster admin username. So this particular user will be able to run anything on the cluster. He can even drain the nodes because cluster admin is so powerful. It is the administrative role. OC ADM policy remove cluster role from user, cluster role username. OC ADM policy remove cluster role from user, cluster admin username. OC ADM policy who can delete user. Okay, this is also a role. Now, default roles for projects are admin. Okay, so users with this role can manage all project resources, including granting access to other users to the project. Basic user, users with this role have read access to the project. Cluster admin is there, cluster status is there, edit is there, self provisioner. Self provisioner means if you are attaching this role to user, then that user can create projects inside your cluster. Okay. By default, whenever you create any user, all the users get this particular role by default. View role. So users with this role can view project resources, but cannot modify project resources. How you can give or attach a project level role? OC policy. For cluster, it is OC ADM policy. For project, it is OC policy. Add role to user, role name, username, and on which project you want to give. So OC policy add role to user. Name of the user is this. Sorry, this is the role. This is the username hyphen and WordPress. So on the WordPress project, the dev user will be able to do basic operations. Okay. I can give admin also, view also, edit also. These all are the project level roles. Now, generally there are three type of users. One is regular user, which we have created in chapter number 3. Okay. System users, as you know, according to the Linux, it is always available to manage the daemons, okay, which is running in background. Okay. Like whenever you install Apache, you get a user named as Apache. Whenever you install NFS, you get a user as NFS nobody. Okay. Where if you want to shut down the system, for shutdown also there is a user available inside the system. So for everything there is a user, which is a system user. System users can't log in onto the system. They can only manage their processes. Okay. And one is a service account. Now service account we will discuss, okay, in this chapter later on. Now this is the guided exercise. So lab authorization RBAC start. You are logging with admin user. Okay. -p Red Hat. This is the API server URL and the IP. 6443 is the port number. Now, if you want to get all the cluster role binding, you can use OC get cluster role binding -o white, and I am grabbing with -e option, that self provisioner. So it is giving me a cluster role binding and the name of that is self provisioner. Now, if you are describing the cluster role binding, OC describe cluster role binding self provisioner, then you can see that this self provisioner is what? A cluster role. Name of that role is self provisioner, and right now it is attached to a group. And the name of that group is system::authenticated::auth. This is the group name. Okay. Now, If you want to remove this role, OCADM policy, remove cluster role from where you want to remove? From the group. So from group, what role you want to remove? Self provisioner. And from which group you want to remove? This is the group name. Clear? So it is removed now. If you are creating any user inside the cluster, that will not be able to create any projects, because generally whenever you create any user, that user is by default added inside this group. Okay. Now OC describe cluster role binding self provisioner. There is no role binding now because we have removed it. So when we remove any cluster role from group, the role binding, cluster role binding related to that will be deleted. OC get cluster role binding hyphen o white self provisioner. There is no role binding because we have removed the role. Okay. Now OC login hyphen u ladder hyphen p Red Hat, and now you are trying to create project. You may not request a new project via this API. Why? Because you do not have permission to create projects. Now I am logging with the admin user. In the previous chapter, we have assigned a cluster admin role to admin user. That's why it is able to do anything. Now with the help of admin user, I am creating a project as authorization RBAC. And now I want to give permission to someone on this project. So OC policy add role to user. What role you want to add? Admin. And to what user you want to give permission? Ladder. And hyphen n you can give the project name. Now, if you want to create some groups, then OCADM groups, new name of the group. OCADM groups, if you want to add some users inside group, add users, dev group, and developer user I want to add. I'm also adding one more group, which is QA, and I'm adding one more user inside this group, which is QA-engineer. Now, OC get groups. So two groups are there and one user are present inside these groups. Now I'm logging with ladder user and using project authorization RBAC. Why ladder is having the permission to see this project? Because we have given the permission. Ladder, we have given the admin privileges on this project. Okay, that's why ladder is able to see this project. Now, so ladder is having the admin role on the project. So he can also change permissions. So OC policy, add role to group. This time I am adding a role to group. What role you want to give? Edit to which group you want to give? Dev group. So whatever are the members of this dev group, they are having the edit permission on the authorization RBAC project. You can also add a role to a group, view QA group, and see OC get role bindings hyphen o white. So admin is there, admin 0, edit, view. Okay, 4 roles we have attached. Okay, to different user. This is generally a ladder user. After that, edit user, edit role we have attached to dev group, view role we have attached to QA group. Okay, and now you are logging with the developer user. Now, developer user was the part of dev group and it is having the edit permission. So with the help of developer user, you can deploy an application, OC new app name. This is the name and what image you want to use, HTTPD:2.4. Now you are logging with and you are trying to change the policy. Now, as you know, developer user is only having the edit permission on the role. So he cannot change the policies. So OC policy add role to user edit QA engineer. User developer cannot list resources role binding in the API group in this namespace. Now you are logging with the QA engineer and you are trying to scale it, but QA engineer is a part of QA group and QA group is having the view role only. So the person cannot scale the application because they do not have permission. Now you are logging with admin user. Again, you are attaching the self provisioner role to this particular group. Okay. So OCADM policy add cluster role to group. What role binding name you want to give? Self provisioner. What role you want to attach? Self provisioner. And what is the group name? This is the group name. And lab authorization RBAC finish. So very simple exercise to do. Now, managing sensitive information with secrets. Now see, generally secrets are what? Secrets are used to store the passwords, sensitive configuration files, credentials to an external resource such as SSH key or OAuth token. Okay. And what are the features of secret? And let me tell you the example of secret. Just a second. Let's do this topic today. I'm creating a new namespace. Anish, Ashish, Nagy there.
Yes.
Yes.
Now, see this practical very carefully. Okay, I'll only tell one time. kubectl get ns. Now I have created a namespace. And now let me deploy a MySQL application. MySQL deployment Kubernetes. Vim mysql.yaml. Now, password for this is Red Hat. Okay, now see. Let's say you have created this deployment. Okay. Tell me guys, tell me Manish, will you really store the root password Red Hat like this in the deployment file?
No.
Let's do it and let's see what is the problem. kubectl create -f mysql.yaml kubectl get all -n grass. Now let's say someone is having a view permission on this particular project which is named as grass. What the person will do? He will describe the deployment. And what he can see, guys, is he able to see the root password?
Yes.
Yes, Manish? Nagy?
Right, absolutely. Able to by describing the particular
Obvious,
deployment.
if anyone is having the view permission, he will describe the deployment and he will see the password. And now he can log in. Obvious. So I don't want someone to see this password. So what will I do now? Instead of storing the information, what will I do? I will create a secret. kubectl create secret. Name is generic. Secret type. What is the name of the secret? Manish. It is Manish secret. I'm using your name Manish. From literal. And from literal equal to. Let's say you are storing the Red Hat password inside password equal to Red Hat. MySQL password equal to Red Hat. Remember this key. Okay. And in which namespace you want to create -n grass. It is created. You have stored a key value pair inside a secret. Okay. And you have created that inside this namespace. Now I want this value Red Hat. So what will I do? I go inside deployment. Instead of having the value or printing the value directly over here, I will write value from secret. And what is the name of the secret? Name of the secret is Manish secret. And what is the key over there? Key is MySQL password. Clear? Now kubectl create -f mysql.yaml. Okay, it is giving me some error. Value from secret. Okay, value from here you need to write secret key reference, and then you need to give the name. That's it. Created. Now you describe the deployment. Guys, are you able to see the information?
No.
Manish, Nagi, Ashish.
No.
That is the concept of secret. So you can store any number of key value pairs inside the secret. Now, let's say someone is having the view permission on the project. What he will do? He will see the secret and he will try to describe the secret. Can he see the value? No, it is written 6 bytes and the person is not having the edit permission. Obvious. So he cannot see the information. Clear? So this is the meaning of secret, and this is a very beautiful practical of secret. Now, so secret data can be shared within a project namespace. If you have created a secret inside Grass namespace, then that can only be shared to the resources within Grass namespace. Secret data is referenced independently of secret definition. They can inject it into the pods. If the value of the secret changes during pod execution, the secret data does not update in the pod. Any secret data that OpenShift injects into pod is ephemeral. Means, obviously, if you will delete the pod, then no secret will be there. Okay. As the object, secret will be present over there. Okay. Now, what are the use cases? You can store credentials. You can store your complete TLS keys or certificates and key pairs inside secret. But for that, you need to create a secret like this. kubectl create secret. The type is TLS this time, not generic. So if you want to store TLS certificate, you can use this --help. It will give you the commands how you can create it. Okay. So OC create secret generic name from literal key equal to this, from literal key equal to this. OC creates OC secrets add for mount service account name secret name. You can add this particular secret and mount this secret inside the service account also. Now, exposing secret to pods. So I am creating a secret named as demo secret from literal username is equal to this, root password is equal to this. And now I can use value from secret key reference name and the key. That's it. So the MySQL root password will be the value of this key inside the secret. Okay. And I can set this particular environment variable directly inside deployment config. Okay, it is something like if you have created deployment and after that you want to make changes, then you can use OC set command. OC set env deployment config demo from secret and the name. So this secret will automatically be injected inside DC. Okay. You can also mount the files as a secret inside the pod. Let me give you an example. Means let me give you a diagrammatic view. Let's say you are having this pod. Inside this pod, you are having a container. And this is your namespace. Now, let's say you have created a secret over here. In this secret, you are storing a file a.conf. Here. Now you want to mount this secret. If you want to mount this file, which is present inside the secret to the container, then what you need to do? You will always mount, just a second guys. Hello. घर पे class 9:30. Now, so what you need to do, you need to map this secret as a volume inside the pod. Okay. And I have already told you this concept. Now, after that, you need to mount this volume on the container at some location like /httpd.conf. So this is how you can inject your files from the secret as a volume inside the pod, and you can mount that volume inside a container. This is the diagrammatic flow. So see, OC set volume you are setting up. In deployment config, you are setting up the volume. Add type is what? Secret. What is the name of the secret? This. And where you want to mount that secret inside the container, that is app secrets. So this is the command. Now this is the guided exercise. So it is OC login. It is creating a new project. OC create secret, generic, MySQL, and it is storing all the informations. What example we have done? Same example. User is equal to this, password is equal to this, database is equal to this, host name is equal to this. Now it is doing one mistake. Generally the name should be MySQL underscore user is equal to my user. Now OC new app, name MySQL, what Docker image you want to use, given the path, everything will be created. OC get pods, it is giving error. Why it is giving error? Because you have not used any environment variable. To run MySQL image, you at least need to pass one environment variable. So now OC set, I'm setting the environment variable. In deployment prefix, I'm using MySQL, so it will apply MySQL underscore after each key. So it will be MySQL underscore user, MySQL underscore password, MySQL underscore database, MySQL underscore host name. Okay, it is generally not needed. Okay, you can ignore this and you can write the information like MySQL underscore user equal to my user directly. It is little bit confusing. From secret MySQL. And now see your pods are running. Now you can take shell inside the MySQL. You can logging and you can exit from it. Now OC new app, same, it is deploying one more application. Same application is also giving you the error. Now you need to set these secret environment variables again. So you are using OC set env prefix from secret, and now pods are running. And you can see the logs, database connection is okay. You can expose the service. You will get a route, and with the route you can curl on it. It will give you the reply. User, password, database, host. That's it. You can check status. You can check random and OC delete project, lab authorization, finish. Got it? These two things have you got, guys? Hello.
Yes.
Okay. Enough for today? Enough for today?
Yes.
Do the practice till 82 page number. Okay. After that, we will be going towards SCC. Got it, guys?
Yes, boss.
Okay.
Yeah, okay, teacher.
And yeah, one more thing, guys. Maybe tomorrow there will be no class because tomorrow is my birthday. Okay. So maybe there will be no class tomorrow.
Happy birthday, Khushi.